Okay, so what I have here is this is estimating the number of water worlds paper, and I have total stars as 200 billion from 0 to 300 million years old, and then from 300 to 600 million years old, you have 200 more billion, so total 400 billion from there, and then 600 billion, and then this is when the water world stages. This is how many water worlds there are. And the reason why I wanted to write this down is that on Wikipedia they have 100% of all claimed stars as being only the ones that shine. So you have 76.45% as red dwarfs. You have red spectrum, which is M, and you have 12.1 as orange, 7.6 is yellow, which is G, and F for white. Bluish white is the A stars, and then the Bravos and the Omegas, and then you can't even see the bar right there. It's nuts. But they think that this is 100% of all the stars in the galaxy. But as a count wise, yeah, sure, there are a lot more red ones, but that's only including the ones that shine, and that's why I did this one. You have the brightest stars over here, which is the O's, and then all the way down to the reds, and they cut off right about here. So that leaves about 200 billion stars along this graph right here. But the count goes up as the objects cool, meaning there's more cooler objects than there are hotter, bigger objects. So this can't be 100%. That can't be 100% all the stars, because clearly they continue cooling and shrinking, which means they become the water worlds. And this is the count. Okay, this isn't a line of evolution. And the reason why I have a count is because these are individual separate objects. It isn't like any evolutionary stage like the Walensky-Taylor diagram is. And the reason why I have that is because the previous video had a bell curve. Now the bell curve is interesting in that the beginning of it is correct, where you had the 3 standard deviations away, and it's mostly the really big hot bright ones. But when you move up here, it doesn't go up and then back down again. That wouldn't make any sense. That would be like saying asteroids are as populous as the really biggest, brightest, hottest stars. And clearly there would be a hell of a lot more asteroids as well. Dead worlds would be here. Asteroids are remains of dead worlds. But basically it's like individual objects, the more visible they are as well. And that being said, this isn't this isn't cut and dry at the moment, but it does kind of show us that. And the reason why I want to do this is to show us that the astronomers, they have the number of the biggest, brightest, hottest stars as being 100% of them. So they made it a closed loop. So whatever evolves with stars, it only evolves the biggest, brightest, hottest ones. And they completely miss the point that the biggest, brightest, hottest stars, they increase in number as they evolve. And they become so freaking numerous that I have a roundabout estimate of 7 trillion full-fledged objects, including water worlds, inside of our galaxy. And the majority of those, the 6.4 trillion, are water worlds in our galaxy. Now I know it sounds like a big number, but I think our galaxy is pretty freaking big. I think it can hold all of those. And they're not going to be visible either. It's only the ones that have really bright spectrums, and they're really they release a lot of energy, and they're also very big at the same time that you see. And mind you, this isn't evolutionary, okay? Because at the very, very end, way, way, way up here, it would be asteroids. And of course, an entire star doesn't become the asteroid, but I mean, it can through ablation. So say you have an object and it orbits too close to a hotter, younger star, it can ablate into it till it's just a single little pebble, and then it disintegrates into dust. That's clearly, possible. But what usually happens is at a certain point, like an asteroid, it just enters into a hotter, younger star, and that younger star just recycles it. I went over that with a different talk. But anyways, it isn't a bell curve. That's all I wanted to get across. I know I have a bell curve in the first video concerning this, but I think another reason why I have this is that that early on when astronomers were classifying these things, they didn't have all the information that they needed to appropriately determine the evolutionary sequences of these objects, because they didn't know how many brown dwarfs were out there. They didn't know how many gas giants were out there. They didn't know how many water worlds were out there. They didn't know. It wasn't until like 1988 that they found the first object that's orbiting another sun-like star, I think, in the galaxy. 1988. That means 1970s, 1960s, 1950s, 1940s, 1930s. All those astronomers throughout all those decades believed that these were the evolutionary sequences of all stars. And anything that shined was a star, and if it didn't shine, it wasn't a star. So this is the mentality they had. But as we're discovering in the 21st century, that was a very myopic point of view. And myopic meaning it wasn't. They didn't look out beyond what they were told. They didn't have any far-seeing ability. So they made the stars here, and if it didn't shine, then it wasn't important. And so they made entire evolutionary models that just focus on this tiny little area right here. And now all the other information, now forget this half right here. All this information, it completely goes up, was ignored because they didn't have the information. It was 1988. But of course I can go over this some more to clarify it, but we're dealing with here the realization that the stars that are visible, that astronomers classify as stars, the basic ratio between the younger stars is 1 to 35, which means 200 billion stars includes the MK, GF, ABO stars, and then 700 billion, or 7,000 billion, which 7,000 billion, wait a second. Yeah, that's a lot, right? Ocean worlds, Earths, gas giants, gray dwarfs, all active stars that aren't dead. Which means when you look at a bright star with a telescope, not Jupiter, not Venus, those are very evolved stars, but when you look at bright ones like Vega or Sirius or, I can't think of all. Sorry, I'm having a brain fart right now, but when you look at those, you're seeing one. Keep in mind that each one of those objects that you see, there's 35 more encircling that or around the vicinity, or exist but don't have an orbit around that hotter host. That's how many objects we're dealing with here in the galaxy. It isn't just, you see one hot, bright, shining star, and then like the astronomers say, we know there's at least one planet around it. Well, they classify it as planet, but what it should be is you'll have one object, and then you'll have another, and then another, and then another, and then another, and then another orbiting this one, and then another way out here, and then that one having like one that's out here, and then maybe even one orbiting that one. So you have these systems upon systems out there, and you're just getting a small little bit of the picture, and that's the whole point of this graph right here, isn't to show the evolutionary line, it's to show how many objects are actually out there that astronomers just don't know are there yet because they haven't supposedly confirmed them. But what this also means is that, more of a science fiction tone, that there's a lot of life. There's a lot of life out there. The galaxy is so full of life, it would freaking blow your mind to really comprehend it. I don't even know how to explain that. It's just we live in a very crowded galaxy, and not all the stars actually shine. A lot of the stars are very evolved, and I think that's the most important part. All right, I think I made this video long enough. Y'all take it easy.